respected Professor Dr. R. Karthikeyan, Professor and Head Department of Mechanical Engineering, as well as Dean of Employment, Training and Progression of our university, most respected Chief Guest of today's function, Mr. Zakir Hussain Manapadam, Polymer Material Specialist from Altron Technologies Limited, Coimbatore, and my dear colleagues in the Department of Mechanical Engineering, the organizing committee members, and students, as well as those who are joined here in the conference as participants. A very warm good morning to one and all. It is indeed a happy and pleasure for me to inaugurate this one-day national level seminar on material synthesis and characterization techniques, which is being organized by the Department of Mechanical Engineering. The Department of Mechanical Engineering is having a very good tradition of organizing most needed the contemporary topics in the form of seminar as well as conferences and symposiums. They are continuing this tradition since their inception in 2014, and still it continues, and I am happy for the department for having organizing such wonderful events and inviting stalwarts of our nation to share their knowledge for the benefit of students. In fact, Dr. Yamuna Devi has rightly mentioned that the human civilization has started with the materials, Stone Age, Iron Age and Bronze Age. I would like to say that this materials makes the world, materials moves the world, and material saves the world. Because without material, nothing can be accomplished in the lifestyle of human being. Materials are everything, and material are making everything. We have plenty of materials with us. There are metamaterials. People are classifying the materials into metamaterials like alloys as well as metals, which are widely used in manufacturing, production and automobile industry. And we have recently the nanomaterials, which are quite interesting, and some people are even calling materials as smart materials, which are having very functional properties. And being a biologist, I would like to also mention about the biomaterials. The materials obtained from biological organisms. They are all having very good applications in every part of human life, be it automobile industry or medical industry or the electronic gadgets. Even you cannot think about any human advancements without the involvement of materials and material science. These advancements in material science actually drive the research on future vehicle technology, the robotics, artificial intelligence, medical implants, especially in the field of diagnostic as well as medicine. The earlier, I would like to recall that earlier, when the bone is fractured or getting any damage, there are less treatments are there. But now the material science have evolved in such a way that medical implants with very good metal alloys have come, and they are saving very precious human lives. And we are having the 3D printing technology in the recent years that this material science has made, and gadgets. Even now, I understand that this Apple iPhone is now coming with a biochip material, which is replacing the silicon materials. Biochips are coming in, and we have semiconductors and sensors, solar panels. Many such applications are there for the material science. I remember the period when I first heard the word LED, light emitting diodes. Thereafter, the materials have been changing. We have been seeing LCD and so on and so forth, so many materials, which is actually enhancing the lifestyle of the human being. And we must not forget, in my personal opinion, I am wondering there's two major materials of recent days. One is lithium-ion batteries. These lithium-ion batteries actually reduce the size of batteries and reduce the size of many equipments, including your cell phones and smartphones. They are really making a wonderful revolution in the field of material science. And the other thing, practically, graphene. Graphene is I think it is made from graphite. Every pencil has a graphite, and this graphene is made from graphite. It is a carbonaceous material. It is said to be 200 times more stronger than the steel, and it is having higher electrical conductivity and very good, very fast heat dissipating capacity. And so it is being used in so many transformational applications, like biosensors as well as I read some research papers that the people who are treating neurological disorders using this graphene material for conduction of nerve impulses. So such a wonderful material is this graphene. Even I learned that the bicycles now are coming made up of with this carbon fibers, especially made up of graphene. And lastly, being a biologist, I would like to mention about a few of the biomaterials which are having medical applications, industrial applications, as well as various other new material syntheses. Like we cannot forget the importance of cellulose, which is one of the most abundant biopolymer on earth, which is we are using it in various forms in papers and other fabrics. Cellulose is a very integrated part of the human being, human civilization. We have very good biomaterials like chitin, chitosan, starch, and I think every people must have taken gelatin capsules. The capsules what you are taking in the form of capsule medicines, they are all gelatin, which is actually obtained from animal sources. It is an animal protein, and there are many such biomaterials. Mainly these biomaterials are having wide applications in the medical industry because they are having biocompatibility rather than any other materials. These biomaterials are having very good biocompatibility with the living system, and they are having very much applications in the drug discovery. They deliver the drugs. Liposomes are one of the biomaterials which actually delivers the various drugs to the target area. And I would like to recall one very interesting discovery. Actually, it's a discovery only. It is a discovery by one of my mentor, Dr. Jnanamani, who is working in the biomaterials division, microbiology division of Central Leather Research Institute. She actually, we all, the marine biologists, long been knowing the biofouling, the problem of biofouling. Animals called barnacles. Actually, barnacles settle on the solid surfaces of ships and other offshore structures. They cause huge problem. Actually, they reduce the speed of the ship and other things. But remember, this madam, Dr. Jnanamani, has approached this problem in a different manner. Actually, the barnacles living in the aquatic environment and the ships also in the aquatic environment. And as far as we know, there are very less glue-like materials which work in aquatic environment. Most of the glues will not work in the aquatic environment, but these organisms, they are able to produce one specific protein. It is a polymer which is working in the aquatic environment, which gets attached to the metal particles, and the animal is firmly attached with the metal particle due to the protein which is being produced by this animal barnacles. So this madam has isolated that particular material, characterized it completely, and she has made a glue. That glue is now being used in the operation, the sealing of operation. Usually stitches will be made while making incision and making operations. So inside this, the glue is pasted, and it automatically gets imbibed with the human cell, because the protein is a biological material and our body is also having biological materials. So they gel very easily. And also the same department only I have done my post-graduation project in an area wherein we developed a gelatin kind of gelatinous material which will be used as a this handy plaster, the plastry people used to make for making dressing in the wounds. Instead of making cotton dressing, they have developed this gelatin based collagen based collagen is also another biomaterial. They made a collagen based dressing which actually gets into the system with the dressing material need not be removed. It will become a part of your body. It is be imbibed by your body. So it will also deliver the drug. So it has dual capacity. So that is the major advantages of being utilizing biological materials in the case of medical research. In short, friends, I would like to say that this again quote the same word what I started with my speech, like materials makes the world, materials moves the world, and materials saves the world. In fact, the techniques for the material synthesis as well as characterization are very much essential to define their function, to improve their applications, and to further expand their usability. So I think this conference seminar may be a very good platform for the budding researchers as well as the faculty members for who are involved in the research on material synthesis to characterize the same. I wish the seminars a grand success, and I personally congratulate the organizing committee headed by the dynamic HOD Professor R. Karthikeyan for having this wonderful seminar organized at the department in a virtual mode. And thank you once again for inviting me to share my few of my thoughts with you. Thank you.